Hi, today we're going to look at Module 3, Lesson 12, and Lesson 13. We're able to combine these two lessons, so just let's follow along because I am going to jump around and skip a few examples. I didn't think we needed to do all the examples. I think you're grasping the concepts, okay? So today we're going to look at ordering positive numbers in their absolute value, ordering negative numbers in their absolute value, and how they compare to one another. And we'll come back and look at the outcomes when we're done to see if we've reached them. So right now, in your notes, for example 1, in the middle of the page, put those numbers in order from least to greatest. So write an inequality statement relating the order integers from the opening exercise. Well, we're not doing it as an opening exercise, we're doing it now. So what's the smallest number here? What's the smallest number here? Negative 12. And that's less than what? What's the next smallest number? The next smallest number? Next. Next. Then. Okay, good. So now they want you to, below each number, below each integer, write its absolute value. So what's the absolute value of negative 12? The absolute value of negative 9? 5, 2, 1, 0, 2, 5, 7, and 8. Are they in order anymore? They're not in order anymore. So ordering integers is different than ordering absolute values. The absolute values of the integers are not in order anymore. Which ones messed us up? The positive integers or the negative integers? Which absolute values messed up our order? The negative ones. So let's take a look. The directions ask you to circle the absolute values that are in increasing numerical order and their corresponding integers. So those are these. We just said those are still in the same order. So let's rewrite the integers that are not circled. Remember, integers are the original number. So the integers are negative 12, negative 9, negative 5, negative 2, and negative 1. Now it asks us to rewrite the negative integers in ascending order. What does that mean? Does that mean greatest to least or least to greatest? Think if you're ascending a hill or descending. I know when I go skiing next week, I'd much rather be descending than ascending. What does that mean? Ascending order means going up, because descending means going down. So let's rewrite the negative integers in ascending order and their absolute values in ascending order below. So here are the integers, but if we write their absolute values, uh-oh. How does my ordering compare? The order of the absolute values is what when you compare them to the order of the integers? They're opposite. So let's take a look. Positive integers, positive absolute value. Do they have the same order? Yup. But what about over here? Negative integers and negative absolute values. Same order or opposite? Opposite. So remember, if you're ordering negative integers that's going to be opposite than if you ordered their absolute values. Okay? Let's take a look. You're given a set of numbers, and first you're going to fill in the two bubbles on top. The negative rational numbers and the positive rational numbers. So take those numbers and fill them in. So 2.1 is positive. Negative 4.5. Negative 6. 2.5. Negative 1.5. Now remember, 0, we talked about that when we went over the homework because somebody asked an excellent question during homework. 0 is not positive or negative. 0 is 0. Remember, 0 is the only one that's not positive or negative. It's the only one with absolute value of 0 is 0. And it's the only one that does not have two integers with the same absolute value. So then we have 3.9. Negative 6.3. Negative 4. 2 3/4. 3.99. Negative 9 1/4. Let's make sure we didn't forget any. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, didn't forget any. Now in the bubble below, let's write all the absolute values. 4.5, 6, 1.5, 6.3, 4, 9 1/4. 2.1, 25 hundredths, 3 9/10, 2 3/4, 3 99 hundredths. Any questions on the absolute values? The next task they're asking you to do is to order the different bubbles. So first they want you to order the absolute values. So this bubble you're going to order there from least to greatest. This bubble you'll order there from least to greatest. E is asking you to order the rational numbers. So your first bubble gets ordered here. Your first bubble gets ordered here. Then take all of the rational numbers and order them there. How do you do this? Because I just told you. Because I said so. All right? Least to greatest. Excuse me, thank you. I'm still not feeling well. So those are the absolute values. Now the rational numbers. Stop after D because I want to show you something. All right, let's take a look here. What can we say about the order of positive numbers and their absolute values? What can we say about ordering rational numbers that are positive and their absolute values? Everybody? It's the same. Positive rational numbers and their absolute value, the order is the same. But here, what about negative numbers and their absolute value? What did we notice happened when we ordered our negative rational numbers with their absolute values. What do you notice about the order? Opposite. Those negatives like to be difficult.
What does subset mean?
Subset means part of the set. So we have that huge set of numbers here. See this big set of numbers? Then we put them into subsets. And then we just took that subset and ordered it. Okay, good question. So now we can put the whole original set in order from least to greatest. So there is our whole original set. We took the subsets and put them back together. From least to greatest. So if we go back and look at our outcomes for today's lesson, the order of positive numbers is the same as the order of their absolute value. The order of negative numbers is the opposite order of their absolute values. And negative numbers are always less than positive numbers. But you've known that like forever. Okay? This one?
Yeah.
Now let's move on to lesson 13. We're going to look at how ordering the numbers, positive, negative, absolute value, in real world examples. Well, this is a hot topic. I have to tell you, today it was so funny driving to work, and we already talked about the weather before. I literally put on one weather channel on the radio, and it said one thing. I hit the button, the next radio station said something completely different. Like, well, which is it? So imagine you're in the car, and one radio disc jockey reported that the temperature outside his studio has changed 10 degrees since he got there this morning. Well, it changed. Does that mean it's warmer or it's colder? What do you think? We don't really know. Using the word changed was not a good choice. It's not specific. So instead of saying changed, what could he have said to say that it got warmer? Everybody? Increased. And what could we use to say it got colder? Decreased. Exactly. So we've been talking a lot about banking, debits and credits. Yesterday we talked about being overdrawn. So there are words that indicate whether it's a positive number and words that indicate whether it's a negative number. And we're going to look at more of those real-world examples today, okay? So listen, Mr. DJ, choose your words carefully. We want as much information as we can have. So we're going to start with number 2. I said we're going to jump around a little bit. So look at number 2 in your notes. Jamie's bank account statement shows the transactions below. Represent each transaction as a rational number, describing how it changes Jamie's account. Did it change it by increasing to a positive number, or did it change it by decreasing, which would have been a negative number? So I see words here like debit. Is debit a negative or a positive? Negative. Credit, negative or positive? Charge. Withdrawal. Deposit, debit, charge. So we can use those words to help us identify what type of integer we need to write. Now again, we have to read the directions carefully because those directions gave us 3 different tasks. So now the second task is to order those rational numbers from greatest to least. Oh, be careful, they got tricky here. Greatest to least. So put those integers below the box from greatest to least. So here are the integers written from greatest to least. So check to make sure that you have your inequality statement written correctly. Now the third part is asking you to explain why the rational numbers you chose reflect the given transactions. Well, how did we know if it was positive or negative? We looked at we looked at the words. The words gave us information. So words like debit, charge, and withdrawal all describe negative numbers. And then words like credit and deposit told us that we were putting money in, increasing, so that's positive. So if we look at the words, those would give us the information if it was positive or negative. I'm sure your parents asked them, do you have a debit card? Do you have a credit card? Talk to them about that. That would help a lot of this make sense. Okay, any questions on number 2? All right, let's go ahead and take a peek at number 3. During the summer, Madison monitors the water level in her parents' swimming pool to make sure it's not too far above or below normal. The table below shows the numbers she recorded in July and August to represent how the water levels compared to normal. So if it's above normal, is that going to be positive or negative? If it's above what it should be, there's more water than it should be, so that would be positive. Above normal, we said was positive. What about below normal? That means there's less water. Negative. So that would help us write our integers to represent each situation. Now that we have our integers, order them. I made a typo on the board. In your notes it says least to greatest. So order those from least to greatest. So in order from least to greatest, there are your numbers. Notice again how the negative sign is right next to the division bar. Because if you put the negative up by the numerator, that indicates that that could be the negative number. So you want your negative sign to be right next to it. Now, the third part of the task is to explain why the rational numbers. So the measurements are taken in reference to the normal level, which is considered to be 0. So above level means positive, below normal means negative. So this is kind of a very wordy answer. So in your homework, if you're going to explain this, you would just write the words above normal refer to positive, below normal would be negative, okay? And try number 4. Changes in the weather can be predicted by changes in the barometric pressure. You're learning about that now in science. Over several weeks, Stephanie recorded changes in barometric pressure shown on her barometer to compare local weather forecasts. Her observations are in the chart below. So rise. That word rise, what kind of a change does rise indicate? Positive or negative? Positive. Fall would be, we just lost the board. So there are your numbers. And then to order them from least to greatest, there you go. And you would just explain how you knew the word rise indicated an increase, and an increase is a positive number. You want to look for those key words. Rise, increase, positive, fall, decrease, negative. What words help you indicate if it was a positive or negative number? Okay, those are the words you're looking for. Yes?
Wouldn't it be like if there were signs?
Oh, yeah, I don't know why those are commas there. Yeah, there should be the inequality symbols. So much for copying and pasting. Good catch. Good job. Now there's one more example I want to show you. You don't have to go through and draw the whole thing. But if you look at the top of page 49, I'm just pausing a second. "49. A captain of a fishing vessel is standing on the deck at 23 feet above sea level. He holds a rope tied to his fishing net that is below him underwater at a depth of 38 feet. So they want us to use a number line. You okay? So look at what this person did. This person used a coordinate grid. So here is 0, which is your x-axis. They drew a little boat. Okay? The boat was in the water a little bit. And there's your person. The person is 23 feet above sea level. So what is the absolute value? 23 feet. But now his rope is how far below sea level? He's 38 below, so that's negative 38. But like we talked about in the beginning of class, we're talking about distance. Can this be a negative number? If I put a ruler down there, is my ruler going to have negative numbers on it? No. It's still 38 feet, even though it's below the number line. That's your absolute value. So what's his total rope? If he has 23 feet above the water, and he has 38 feet in the water, how long is his rope total? His rope is 61 feet long, because he's got this 23 feet above the water and that 38 feet below the water. I just thought that was neat how they showed the picture to see the above and the below, and how they drew that on an X and Y axis on the coordinate grids. I just thought that was kind of interesting. So we summarized lesson 12, and for lesson 13, when comparing values in real-world situations, descriptive words will help you to determine if it's a positive or a negative number. That's very important when you're trying to solve. Please stop clicking and packing up. Let's listen. It'll help you when you're solving real-world problems. And it'll help you make inequality statements. Will also help you decide the absolute value and inequalities. Okay? Good job. We got everything accomplished.